So we're going to graph quadratic inequalities in two variables, but first we should really refresh how to graph any inequality in two variables. So we'll start with a line. Well, firstly you'll be given some sort of line. This is linear because all of its coefficients, all of its variables have a highest degree exponent of 1. Let's make that this 3. So I would want to put this in slope-intercept form so I can very easily graph it. If you know how to do it from standard form, you can do so. Let's solve for y. Whoops, that was an accident. Oh, now I know how to use this pen, so use a right click. Alright, so subtract 2x from both sides. We'll get 3y is greater than or equal to negative 2x plus 3. We'll divide both sides by 3. And that says y is greater than or equal to negative 2/3, because that doesn't go into it evenly, plus 1. Now, if we did divide by a negative, the golden rule would come into effect, and we'd have to flip the symbol here. So we're not doing that. And again, this is not the focus of this video. This video is to remind us how to graph inequalities. So this is my coordinate plane. My y-intercept is at 1, so we'll plot that at 1. Alright, so this is 1. The slope is a rise of negative 2, so this is up and down, that's our rise, so it says go down 2, so that's down 1, down 2 is here, that's down 2. The run is left and right, 3, which is positive, so we'll go this way 3, 1, 2, 3, that's a distance of 3. So using that we can graph our line, which goes about that way. Obviously use a straight edge. Now, the reminders about the, let me erase all this excess stuff we don't need. It's just here for reminders. You can use it to help you or not. Alright, how do we graph the inequality? Well, if we have y is greater than the line, we shade above. To figure out which side of the line is above the line, you pick any point on the line and move up. So I'm going to pick this point right here, and I'm just going to move up. That tells me that this side of the line is the side that needs to be appropriately shaded. If it was y is less than, I would pick any point and go down. Alright, so since this is y is greater than or equal to, we shade this way. So these are the set of points that satisfy this inequality. That's one way to do it. If it was y is less than, we would shade this side. That's less than. That would be y is less than or equal to negative 2 over 3x plus 1. Let's imagine this was y is just greater than, strictly greater than, not equal to. In that case, our line needs to be a dashed line. The dashed line is like an open circle on the number line. It indicates that the line itself does not satisfy, points that satisfy the line do not satisfy the inequality, because 3 is not greater than 3. So values that satisfy this equation actually don't satisfy the inequality. So again, this would be shaded above, like so. Okay, so hopefully this was a good refresher on how to graph a line, how to graph an inequality, or how to shade an inequality, whether to use a dashed or a solid line. To do that, I'm going to address two other things in reference to lines, and then we're going to look at the at graphing a quadratic, because that's going to take a lot longer. So I have like 30 seconds to do the rest on everything else on linears. Alright, so crossing all this out. Alright, so horizontal lines. Come in the form of y equals b, where b is the the y-intercept. So if we had y is greater than 2, that would be this dashed line here. And since y is greater than 2, that's above, so I pick any point on the line and go up, and that would be my shaded region. Alright. Whereas if we had a vertical line, that has the format of x equals b, where b is the x-intercept. So if we had x is greater than or equal to -5, that would go over here. This is -5, there's my x-intercept. It is equal, so I use a solid line. Greater than says values of x that are greater, which are located this way. Alright, so that's a reminder of horizontal and vertical lines. It covered the when to use a dashed and solid line again. Alright, getting into why horizontal lines are in y equals b form and vertical lines are in x equals b form is another story, which we're not going to spend time on, because again, that's not the purpose of this video. So let's get into what we are here for. Okay, so graphing parabolas. Let's just make one up. Y is, let's use red, y is greater than or equal to x squared plus 5x plus 6. Firstly, if you have a graphing calculator, just substitute this into it and make a table of values and plot them. That'd be the easiest way to do it. Now the hard way would be to use these values a, b, and c. This is in standard form, this is y is equal to ax squared plus bx plus c. So, and find the axis of symmetry, which is this formula, axis of symmetry. Okay, which can be found by this formula here. X is equal to minus b over 2a. Axis of symmetry is the line that cuts through your parabola. So in this case, x is equal to minus 5 over 2 times 1. So x is equal to -2.5. So that's the location of our vertex on our parabola. So if we make a table of values, x, y, I like to put my vertex in the middle, 2.5, and then I like to go up, down 2 values, and up 2 values in order to graph my parabola. So my parabola is going to be somewhere over here. This line is somewhere over here, so it should come out to be that way. Just going to briefly do this. I don't really want to take that much time. Substituting -2.5 in here. Let's use a calculator. So that's 2.5 negative squared is 6.25 plus 5 times -2.5 plus 6 is -1/4. Doesn't seem to want to write at the moment. Is it good? So that is -1/4, -0.25. Now I know that I've kind of caught on that when my a value is 1, going up 1 will increase this value by exactly 1. So that will be 0.75 and 0.75. It's symmetrical in both directions. I also know if I go up 2 values from my vertex, it actually increases by an additional 3, so this will be 3.75 and 3.75. That's just from my own experimentation. The reasoning I can't give you right now. You can calculate all of them by hand, but I don't see the point if I know this. So my vertex will be down here at negative 2.5, so it's negative 2.5, down 1/4, so it's right about there. Goes up 1 when I go over 1, that's why I did that. This goes up 1 when I did that. So these are my points. I'm just plotting these points here. So here's my parabola. Okay, put some arrows to indicate it goes on forever. I should label it. This is y is equal to x squared plus 5x plus 6. Now if I had a strictly greater than, this would be a dashed line here. Alright, so matter of fact, let's make it that, because I find that to be more interesting. It also catches on more errors, so if that's strictly greater than, then this is actually a bunch of dashed lines. Alright, so just like with graphing a linear system of a linear inequality in two variables, we do the same thing. We pick, we want to graph above the parabola, so we pick any point on the parabola. Let's do that in blue. And we go up from there. So just picking the vertex, if I go up from there, that puts me here. So this is the area where y is greater than the parabola. Whereas if we make a small change here, and make this a less than, then we pick a point on the parabola and go down, which is here, which would be this area. This is where every point is below the parabola. Alright, so it works the same way as an equation. So the axis symmetry is useful for locating the center of your parabola or your vertex, which would make the center of your table. You can go up or down a couple values to graph the parabola. Remember, not equals means dashed line, with equals is a solid line. Less than, shade below, pick a point and go down. Greater than, pick a point and go up, shade above. Alright, so that kind of covers everything, I think. Are there other ways to find the vertex? Yes, through completing the square, which we'll be looking at later on in the course. So we haven't really talked about that yet, but you are supposed to know how to find the axis of symmetry. Your calculator also has some features. If I didn't have so many tabs open, I would have used the calculator before. So I did get it open, so let me quickly do this for us. So we have y equals x squared plus 5x plus 6. So I just want to see what this parabola looks like. It looks approximately like the one in the graph. If we change this to this setting, this is shade above, so this is y is greater than the parabola. Going back, this is y is less than, that line shades above the parabola, this shades below. So that's y is less than the parabola. This is a good look at it. Let's look at the table of values real fast. You'll notice that my vertex is directly between these two values here, because I had partial points. If you press second window, which is the table settings, I can change my counter to start me at my vertex, which is negative 0.25, negative 0.25, and if I go back to the table, you'll see whether my values were close or not. From the looks of this, I did misplace my value. Oh, it's 2.5. That explains it. Out of time.